Hi guys, welcome to another lecture in Dowlath revision series. We are up to video number 14 and today's class is all about momentum. So when we talk about momentum, we firstly symbolize it by common P, and that is defined as a vector quantity, which is the product of mass and velocity. And of course, the unit for momentum is kilogram meters per second. Now, in today's class, we're going to look basically at a new concept, which is the principle of conservation of momentum. And this basically deals with how bodies behave when they undergo a collision. So it states that for two or more bodies involved in a collision, the sum of the momentums before the collision. So for each body, you're going to find the product of their mass and velocity and add them up. And you're going to compare that to the net sum of the momentum of each body after the collision. And based on that, it's supposed to be equal, right? That's what the law is telling you. Here, what I did is I showed you diagrammatically how we can apply the law. And again, there is no fixed way that bodies behave after a collision. It is all dependent on what is given in the question. So we could consider now two masses, and in this case, M1 and M2 are moving with velocities to the right. Because they are vector quantities, you normally consider a direction as positive. So here we consider all bodies moving to the right as positive. So then you would have now, after the collision, the squiggly line represents the collision, they would have moved with new velocities in their preceding directions, right? In the same directions they did before. So all I did is I considered the product of mass and individual velocities, and then I added them up. Now, there is something called a head-on collision that you need to be aware of. And basically, in a head-on collision, bodies are moving towards each other. When bodies are moving towards each other, remember previously I considered all velocities in this direction as positive. So if my bodies change direction, then they would have had a negative sign here. So what I would end up having is that my expression will look like this: M1U1 minus M2U2. After they have collided, the net momentum can be reduced to 0, which would indicate that the bodies would remain at rest. Now, when we talk about collisions, we have two specific types of collisions. One is you have elastic collisions, and two, you have inelastic collision. Now, an elastic collision is where total momentum is conserved. For an inelastic collision, total momentum is always conserved. Total energies in both types of collisions are conserved. The only fundamental difference between an elastic and an inelastic collision is that kinetic energy is not conserved. Now, for those of you who are not familiar with the term kinetic energy, it's very simple. Kinetic energy is categorized as the energy due to the motion of a body. So from the time a body is physically moving, it has or possesses kinetic energy. If the velocity increases, there is an increase in kinetic energy. If the body is at rest, there is no kinetic energy. And it is given by an equation, so we can calculate it. Energy is measured in the joule. And it is determined by the equation, a half mass by velocity squared. So once you get your velocity and you square it and you multiply it by the mass, you can calculate the kinetic energy.